Lesson 3, Linear Inequalities in Two Variables. Expressions of inequality in two variables are usually plotted on the Cartesian coordinate plane or rectangular coordinate plane. Any plane that you can draw two axes, the vertical axis and the horizontal axis. The two variables are usually x and y by default unless otherwise stated. Here, broken line represents strict inequality signs, this or this, while thick straight line shows weak inequality signs, this or this. We always use the linear equation equivalent of equality to get the 2 points necessary to plot the straight line. This is what I'm saying here. When you want to plot the graph, you need to convert or change the given inequality sign to equality so that you have equation. Then you can now solve for x and y for you to have the ordered pair or table of values after making y the subject of the resulting equation. Y is always the dependent variable. It stands alone on the left hand side. Some inequality regions are shown below shaded. If you have y less than or equal to 0, you shade the region below. You have y greater than or equal to 0, you shade the region above. If you have s less than or equal to 0, you shade the region left of the s axis. And when you have s greater than or equal to 0, you shade the region right of the s axis. S less than or equal to 0, you shade the region left of the s axis. Examples. The instruction is show the expressions below on a graph. Example 12. S plus 2y minus 6 greater than or equal to 0. Solution. First thing is to change the inequality sign to equality and you make y the subject of the equation. So this symbol, you change it to equality to enable you get the ordered pair or table of values. Next thing is to make y the subject by transferring minus 6 and plus s to the right hand side, divide both sides by 2 and y is equal to s. Y is equal to 6 minus s over 2. You should know that in graph plotting, the values of s are always given, and when they are not, you assume a reasonable range of s values, not too small, not too large. So here I'm taking minus 3 to plus 3, and you get the corresponding values of y using this equation. Now let's get y when s is minus 3. So y is equal to, you have 6 minus, then s is minus 3. You close the bracket all over 2. Minus minus is plus. So 6 plus 3 is 9. Divide by 2, you have 4.5. If you do the same thing with the rest values of s, you have the corresponding values of y. You have the table of values, the graph notes, you draw s and y axis respectively. Now this graph I'm using, each box is 5 lines. That means 1 cm by default, and the scale is 1 cm to 1 unit on both axes. This scale implies that one line is equal to 0.2. So let's plot the first point. When s is minus 3, this is minus 3. So from 4, you have 4.2, you have 4.4, 4.6, 4.8, and you have 5. So 4.5 is in between 4.4 and 4.6. That is somewhere here. Then you plot the remaining points. Note that a thick line is used to join the points together because the given symbol of inequality in that problem is weak, greater than or equal to. Because it is greater than or equal to, the region above the line is shaded. Hence, the solution set is the region shaded above the line. If you take any set of points in this shaded region, surely it will satisfy the given inequality. Example 13, you have y less than s plus 10. You change this symbol to equality and you have y equal to s plus 10. Y is already standing alone, so you don't need to do anything again. Then let's have the table of values, the same range of values of s from minus 3 to plus 3. You get y when s is minus 3. You come here, you replace s with minus 3, and y becomes minus 3 plus 10. That is 7. When s is minus 2, y is 8, and so on. You have the table of values, the graph notes. You draw the s and y axis. The scale on the s axis is 1 cm to 1 unit, which implies one line is equal to 0.2 units, and on the s axis 2 cm is equal to 5 units. So this scale means that 2 lines is equal to 1 unit. The first point, minus 3 and 7. So this is minus 3. After 5, the next 2 lines is 6. The next 2 lines is 7. So you have 7 somewhere here. And you plot the remaining points. Now, broken line is used to join all the points together because in the given inequality, the sign there is straight. That is less than y less than s plus 10. For that reason, the region below the line is shaded. And you have the solution set in the region shaded below the line. Example 14, draw a graph of the region that contains the set of points for which 3s plus y is less than 6. Solution, make y the subject. You have to transfer plus 3s to the right, and you have it in this form. You need to change this symbol to equality, and you have y equal to 6 minus 3s as the boundary line. In this example, I want to use the approach of ordered pair. In that ordered pair, you set s equal to 0 and you solve for y is equal to 6. And you set y equal to 0 and you solve for s equal to 2. Now let's find out if s equals 0, y equals 0 will satisfy the inequality. So you have it in this form. You replace s with 0, replace y with 0. Now at the end, you have it that 0 is less than 6. So s equal to 0, y equal to 0 are true. They satisfy the inequality. This graph is very simple because we have just 2 points. When s equal to 0, y is equal to 6, and when y equal to 0, s is equal to 2. And you use broken line because the given symbol is straight, less than. So you shade the region to the left of s axis or the region below, because you have y less than 6 minus 3s. It follows that this part you have here is y is greater than 6 minus 3s. But this is the part we are interested in, this part, by the given symbol of inequality. Next, we shall consider simultaneous inequalities. Simultaneous solutions to inequalities involve solving together 2 or more inequalities to obtain a common solution set. A common solution set. Example 15 illustrates the following inequalities on graph paper and shade the region which satisfies all 3 inequalities at the same time. You have this, and this solution. Make y the subject in the first 2 inequalities and find their ordered pair. We are not constructing table of values here. So this is the first inequality. You make y the subject, that is 5y first, by transferring minus s to the right. You have it in this form. Divide both sides by 5. You have this result. You change this symbol to equality. You have this expression. When s equal to 0, if you put 0 here, y becomes 2. And when y equal to 0, if you put 0 here and solve for s, you have minus 10. In the second inequality, you do the same thing. You make y the subject, that is 4y first. You have it in this form. Divide both sides by 4. You have this result. If you interchange the position of y and the other side, it becomes y less than 3s minus 1 over 4. You change this symbol to equality, you have this result. When s equal to 0, if you put 0 here, you have minus 1 over 4. That is minus 0.25 for y when s is 0. And when y is equal to 0, if you solve for s, you have 0.33. The third one, you simply change this sign to equality and you have s equal to minus 1. Next thing is to plot the various ordered pair on the graph paper. This is a graph showing the solution to the set of inequalities above. You have the first one from the ordered pair. When y equal to 0, s is minus 10. When s equal to 0, y is 2. These are the points for the second one, and the third one, s is equal to 1, minus 1, minus 1. There is no y at that point, so it is a straight line, and the line is broken because of the straight symbol. Now you find out that the solution set is the region bounded by the three inequalities, represented with point A, point B, and point C. The scale used is 2 cm to 5 units on the s-axis, which implies that one line is 0.5 units, and on the y-axis we have 2 cm to 2 units, which also means 1 cm to 1 unit, and one line is 0.2 units. So we take point A. If you trace this point to s-axis, you have minus 1. If you trace that point to y-axis, noting that one line is 0.2, you have 1.8. You take point B. If you trace this point here to the s-axis, you have minus 1. Now, if here is minus 1 and here is minus 1.2, in between is minus 1.1. That is what you have here. Therefore, point C, if you trace this point down to s-axis, one line is 0.5. So if you trace from here, you have 0.5, 1, 1.5, 2, 2.5, 3.5, 4. So in between 3.5 and 4, we have 3.55. And if you trace this point to the y-axis, you have 2.8. So from the graph, the region that satisfies the inequality simultaneously is A, B, C. Any point in this region satisfies the set of the inequalities. End of lesson 3. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you need to give your life to the Lord Jesus Christ and confess Him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye and stay tuned.